Yes, hello friends. So this is the video editorial for Weekly Contest 480, which is currently going on. I've solved all the four problems, so we'll discuss all of them. Yeah, the contest overall was quite easy. I think in under 30 minutes, everyone should be like, if you have some practice, you should try to target all the problems in under 30 minutes. My performance, like I woke up 15 minutes late, so that's why every submission of mine starts after 15 minutes. Yeah, that's it. Let's discuss question number one. Okay. So question number one, what it's an easy problem. It says absolute difference between the maximum and minimum k elements. So the question says you are given an integer array nums and an integer k. Find the absolute difference between the sum of the k largest elements in the array and the sum of the k smallest elements in the array. Return an integer denoting the difference. So basically, you are given this array, right? And for this array, the okay. Yeah. For this array, we'll find the greatest k equals to 2, right? So, what is the greatest two elements? That is 5 and 4. What is the smallest two elements? That are these two, 2 and 2. And this sum is 4. This sum is 9. So, the answer would be 9 minus 4. That is 5. Yeah, so you can implement this pretty easy. You can just sort the array. Just sort this array. It just becomes 2, 2, 4, 5. Then pick the first k elements, last k elements. Let this sum be S2. Let this sum be S1. Your answer would be S2 minus S1, right? Pretty simple implementation. We can even see the implementation right now. Yeah. So as I said, we'll just sort the answer. In S2, I will just store the maximum elements, maximum k elements. In S1, I will store the minimum k elements or the first k elements. Then I will just iterate over the k. In S1, I will add the first num si, and in S2, I will add the reverse of it, or basically the back element, and then finally we'll return HTML assessment. Yeah, pretty simple. Let's go to the next question. And this is also a pretty simple question. This is just implementation of the idea. You will have to write a little bit of code, but it's a pretty simple question. It says you are given a string S consisting of lowercase English letters, each separated by a single space. Determine how many vowels appear in the first word, then reverse each following words that has the same vowel count. Leave all remaining words unchanged. Return the resulting string. So what the question says is, see, okay, yeah, no, okay, let me remove this. So this is the string for the first case, right? So if this is the string for the first case, then what we need to do is basically this is a first word, right? This is word. So because the string says that each word would be separated by a space. So this is first word, this is second word, this is third word. How many vowels are in this first word? There are one vowels A. How many vowels are there? There is one vowel A, and there is E. So vowels are A, E, I, O, U. If you did not know, you can thank me for teaching you this thing. But this has two vowels. Now the question says for each word that has the vowel count same as the vowel count of the first word. So first word has one, and this has one. So this would get reversed. So it would become cat space DNA mice. Mice. So this becomes this because the word which has the same vowel count as the first word will get reversed. The key point to note is that we are not reversing the first word. The first word would obviously have the vowel count same as the first word, but we are not considering the first word here. We'll reverse this, and this becomes our answer. Yeah. So how can you do this? It's pretty simple. We will first break a string because this is given to us as string, right? String s equals to. We'll first have to break it into a vector of string words, right? How we can do this? I don't. There might be a inbuilt function that does this in JavaScript and all those language. Python also. There's a dot split function, and I'm not 100% sure if this is for CPP or C++, but that's besides the point. We can implement this. It's a pretty simple function to implement. Then after breaking this down into words, so what would our words array look like? It would be cat and mice. Then we can get the vowel count of the first word. So vowel count we'll store in some VC variable or in VC. Yeah, in a VC variable, this would be one. Then we can iterate over all the words. If the vowel count of the ith word, or we can say if VCI double equals to vowel count 0, or the vowel count of the first word, basically VC 0. Then we'll reverse the word, and then we'll add to answer string. Now, the key point to note here is that answer is also a string, right? So yeah, we can go over the code now. Yeah, we just need to implement this. So as I said, I have implemented this get words function for the string s. So basically, what we are doing is traversing this. How will you do this, right? It's a pretty simple thing. So give me one second. So how will you break this down into vector of string? See, you can traverse the string if the character si basically is an empty space. Si double equals to empty space, then the basically the string before it is a word, right? Because this is space separated. So we'll do answer, or the answer is basically the words. We can make this words here. Words dot pushback, not pushback word, right? And if it is not the case that si is not equals to, then we'll just add it to a word, and here we'll do word equals to dish, and then we'll do word plus equals to si. So this is basically that si is not equals to, so else case basically. So what we're doing is we'll traverse the first string. This is not equals to empty, so we'll add it to our word string. So word becomes C. Then we'll traverse this. This is also not empty, so we'll again add it to word. Then we'll traverse this. We'll add it to word. Now this becomes cat. Now this is empty, so we'll do word dot push back words. So in a words, so words becomes cat, and then we'll reinitialize a word, because see, this cat should not concatenate with this and, right? The next word basically. And then we'll just repeat this again and again. So this will break this down. We can even see this in code, right? So we are traversing over all the characters in the string. In the answer, I'm going to store all the words. If this si is an empty character, then we'll push back into answer the current word, and set the current word equals to 0, else I'm just adding it to the current word, and final word also, right? Because in the final word, so what would happen here when the loop eliminates your current, or your current word would be mice, and there's no like space after the mice, so that's why we should also push back finally the current word, right? This is a kind of pattern. If you write this code once, you will always remember this code. Yeah. So also answer dot pushback current, and then return answer. So this will give you all the words in the string. So yeah, all the words in the string. Then in VC, I'm storing the vowel count of the first words. How we are doing the vowel count is pretty simple. Uh, yeah. So the question says that the string has all the lowercase English letters only. So in the lowercase English letters, the vowels would be A, E, I, U, U. I just traverse over the word, and if it is a vowel, I do answer plus plus return answer, and this return answer becomes VC here. So in VC, I'm storing the vowel count. Then yeah. Yeah. So the first word will be put in place, right? The first word, or the first word. So the words are cat and mice. Now here, what we need to do is, now this is a words. Now we want to make this back into the string, and the space separated string of, right. So what we'll do is first put cat, right, and then we'll need a space. I'm denoting space here by underscore. Then and now we'll have to reverse it first, then add it, because the vowel count matches with the first word. So it will DNA, then space, and then mice, because the vowel count does not match it. So how you can do this is, before you can put the first word as it is, because it is not going to get changed. Then put a space, then check for the second word. If it has same vowel count, reverse it, then add it, else just add it, and then add a space, and so on, so on. Right. So that is what we are doing here. I know how many words are there. I go over all the words before adding any word, because I've already added 0th word. So that's why I'm adding a space before every word. So before adding every word after one. So like before adding DNA or the second word, I'm adding a space. Before adding third word, I will also add a space, right? Answer plus equals to a space. Answer is basically the final answer or the final, like this order, right? This thing. Yeah. Now I get the ith word. If the I get the vowel count of the ith word, if the vowel count of the ith word matches with the vowel count of the first word, I will reverse it. After reversing it, I will add it, or else I will add it directly, right? So this works. I am not going to submit it because it will take my last submission, but this works. Now let's go to the next question. Now this question, if you read this question, you will think, okay, this is a very hard question and like this needs DP and all of that. The key thing, I do not know. Let me rant about this. But okay, let's read through the question and then I will rant about my problem with this question. You're given a circular array balance of length n, where balance I is the net balance of the person I. In one move, a person can transfer exactly 1 unit of balance to either of their left or right neighbors. Return the minimum number of okay, I don't know what happened to my voice, but return the minimum number of moves required so that every person has a non-negative balance. That it is, if it is impossible, return minus one. Note you are guaranteed that at most one index. Oh, it's actually written here. I did not need read this. So I took like 15 minutes, like solving this and thinking, okay, this is very hard, but I did not read this. You're guaranteed that at most one index has a negative balance initially. I thought this was only written in the constraints. I was going to rant about this, that this should not be in the constraint, this should be in the problem statement. But yeah, in the problem statement is it is in the problem statement. I'm just stupid and cannot read properly. So yeah, that's beside the point. Yeah, this makes this question very easy because see, I took like 15-20 minutes thinking that okay, if there are many, the problem is if there are many, uh, there are many negative values. So if there's many negative values, what could be the problem? So let's say the question has allows us many negative values. So it could be like 2, 2, 1, 5, 0, 0, 0, 0, or rather minus 5, 3, right? If 3, 0. So if there are many negative values, the problem is that see, now you have to make a choice for this minus 2. You can either get the, see what the question says, let me explain it, is that let's use this case 5 let's use this case only. So if there are, okay, no, we should not use this case because the question does not allow this case. Okay, I'm all over the place. Okay, let's start again. So what the question says is, you are given some array which is a circular array. The point of it being a circular array is it is in this form: 5, 1, minus 4, and this would be like this, right? So each element has a left neighbor and a right neighbor. So left neighbor of like the first element would be the last element, and similarly the right neighbor of the right element last element would be the first element. So this forms a circle, right? That's fine. Now the question says that this is a value or a balance of a person. We can just assume this is a value. Now what we want is that each value should be greater than equals to 0, right? So now the problem is that this value is not greater than equals to 0, right? We want this value greater than equals to 0. How we can do this is that each person or each index can transfer its value to its neighbor. So there would be two neighbors, so this can transfer its value to its neighbor. So if let's say we do one transfer from this one, so what would our array become? It would become 5, 0, minus 3, because this one gets transferred here. Now this is still has a value that is negative, so 5, 0, minus 3. Now we cannot transfer from this again because then this would become negative, and that is not optimal. Then we'll have to do some operations on this. So we should target this. So we can put one value here, we can put another value, or we can put three values. So in the final case, our answer would be 2, 0, 0, right? So this is a final array. And how many operations did you need to do? You did one operation, you did two operation, you did three operation, you did four operations. So our final answer is 4. We want the minimum answer. We want minimum answer such that this condition, that each value is greater than equals to 0, is satisfied. Okay. And the question guarantees that there is at most one negative index, or at most one negative value. Now, if this was not the case, this is what I was saying. If this was not the case, this would become a very hard problem, because see, here there are two negative indexes, this and this, right? Now, here you will have to make a choice of which negative index to prioritize, or basically see for minus 2. What if we were to be greedy, we would pick this 2, right? If we pick this 2, and we'll then get 0 0 2 1 minus 5, and a lot of zeros, 3 0, and yeah, then we'll come to minus 5. Then we'll see, okay, we can put 2 here, 1 here, but this would still be minus 2. For this minus 2, this 3 has to come. So basically this would become 0 0 minus 2. Now for now this 3 has to do a lot of operations to come here, right? So this is not the optimal way, right? So we should not be greedy about 2 or this minus 2. We should be actually use 3 here, because if we use 3 here, so this will take less operations, and this we can use like 2 to 1. These all remain, and this would can solve 5. But that's beside the point. Like, this is not the question that we are going to solve. What the question we need to solve is pretty simple, and there's only one negative index. And why there's only one negative index is very helpful is, see, whatever is the negative index, let's say, what was the question? 5 1 minus 4, right? 5 1 minus 4. If there's only one negative index, then we can be greedy about this index. What do I mean by being greedy? Because see, if I put a value from, let's say the negative index is ni, and I put a value from L to here, how many operations do I need to do? I put one, like, I transfer one of L, where I know that L would be greater than 0, and I put here. So what? How many operations do I need to do? I need to do ni minus L, or absolute of this, absolute of ny minus L. So that is basically a, if I transfer one thing from here, I will have to do one operation. If I transfer one from here, how many operations do I need to do? Again, this is cyclic, so I need to do one operation. So, because these are neighbors. If it was like 5 5 2 1, minus 4 3 minus 4 1, let's say this, then we'll for here, for this one I will have to do 1. For this 2 I will have to do 2. I'll have to do this. For 5 I don't need to do 3, I need to just do 2. So 5, because this is cyclic, 1 minus 4, right? So if this is the case, then how should I do this? Because see, if I here, if I, yeah, the for transferring one value for each index, this is the value absolute of ni minus L. So that is from immediate neighbor. I can just do it in one operation. For the next of immediate neighbors, or the neighbors of immediate neighbors, I will have to do two operations. Then we can be greedy. We can first transfer all the values from its immediate neighbors, because they will only need to do one operation. If our value is still is still negative, then I will transfer the values from the neighbors, the second neighbors. So first we'll do with first neighbors. First neighbor will do one operation for each value. Second neighbors we will do two for each operation, and then third neighbor will do three for each operation. So how can we classify? We are just classifying our neighbors. So the first neighbors are the immediate neighbors of it, right? This and this, and two neighbors are the neighbors that are at two different indexes. So it is this and this, right? And how we can do this is basically keep let's say this is a negative index. We'll first initialize L as ni minus 1, R as ni plus 1. Again, this would be under modulo n, because we are dealing with modulo n, because we are dealing with a cyclic array. So if you do not know, like, how we do deal with cyclic arrays, is we basically always keep an index under mod n. So if, let's say, this is the last element here, right? 5 1 minus 4. I have 5 1 minus 4. So this is 0 1 2. The size of the array is 3. So what would be the right neighbor of it? If it was like a normal array, that will say the right neighbor is I plus 1, right? But in a cyclic array, it just becomes I plus 1 mod n. So 3 3 mod 3 0. And that is the correct case. And similarly, what would be the left neighbor of it? It is I minus 1 and the mod n. So I minus 1 is 1, and 1 sorry, 0 minus 1 is minus 1, minus 1 mod 3, or we can say minus 1 plus 3 mod 3, that is 2, right? So this 2. That makes sense. That, like, you should know this, but yeah. So we'll find the first neighbor L and R, again under model. Then if this does not resolve a negative index, we'll then go to the second neighbor, and then we'll put its value here. And for each transfer, like each value transfer, for second neighbor we'll need to do two operations. And then if does not resolve it, then we'll do three. Then we'll go to third neighbor. So let me show you how I implemented this. I first of all got the total sum of the array, and I check if the total sum is negative, because if total sum is negative, we cannot resolve this condition. So, like for this case, minus 3 and 2, if even if we transfer all the 2, it will become minus 1 0, and like that the all the values are not greater than equals to 0. So that's why we should return minus 1, that this is not possible. Okay, yeah. So I found the total sum, because total sum should be positive. That in that case only, all the transfers would make sense, and it would actually resolve the error or the negative index. So if it is less than 0, I just return minus 1, and that this is an impossible case. When I find my negative index, I initialize like negative index as minus 1. I go over all the balance. If balance I is less than 0, negative index equals to I, and I break, because I know there's only at most one in negative index. Now, if negative index is minus 1, I went over all the balances, and none of the balance is negative. So I should return 0. Why should return 0? Because there is no negative index. I do not need to do anything. As I said, now uh, I in rec, which is like my requirement variable, I just store that what is the value I need to resolve. So rather than dealing with rec as negative, or the like, see, how will you do this? So 1 to minus 5, right? Your requirement becomes minus 5. I just make it to 5, and for each like neighbor I minus it till it becomes till it is greater than 0. You can do this the other way around as well, but this is simpler to implement, I think. So I just make requirement equals to 5, and for each neighbor I just minus it. So like here I will just minus 2 and 2, so that becomes, for first neighbor it would become 1, and then I will go to the second neighbor. Yeah. So as I said, in L I am storing the index of the index before it, negative index, and in R the index just after it in a cyclic way. And I will go till requirement is greater than 0. And D is basically which neighbor I'm dealing with. So first I'm dealing with the first neighbor. I calculate the sum of this neighbor. So balance L plus balance R. This is the total value that this neighbor can afford to transfer. Now, now I see if this is greater than S. So the key here is C. Uh, if the array is something like 1, 5 minus 4. So first neighbor can transfer how much value? The first neighbor of this can transfer 1 plus 5, that is 6. Do we need to transfer 6? No, we only need to transfer 4. So that is what we'll do. If the value that it can transfer is greater than requirement, then we'll transfer all of the S. Else I will only transfer rec, because yeah. So we check if requirement is greater than S, we'll transfer all the S or all the value in this neighbor, and we'll do requirement minus equals to S, and how many, for one you are doing D operations, because it's the dth neighbor, so it will have to do the D jumps to transfer, and for S values it will obviously do D into S operations. Else, so else is basically that S is greater than equals to rec, so we'll only need to do rec transfer answer plus equals to rec into D, and requirement finally becomes 0. And then we'll go to the, so we were at the first neighbor, then we should go to the second neighbor. So that is what we are doing here. And yeah, so this works. Let's go to the next question. So the next question is the D question. I think if you know the topic how to solve this is a very easy question. If you do not know how to what the topic of this question is, it is a bit tricky to implement by yourself. Okay, so Let's straight to the question first. It's a hard problem, but I don't think this is the hardest problem. You're given a string S of length n, consisting only of characters A and B. You are also given a 2D integer array queries of length Q, where each queries I is of one of the following. So you're given a string and you're given some queries. The first query is 1j. 1j basically means flip the character at index j of S. So if it is A, it becomes B. If it is B, it becomes A. This operation mutates S and affects subsequent queries. So this is kind of like an online queries question. So what is the difference between online queries and offline queries? Is in offline queries you are given all the queries and then you can answer them. In online queries you will be given a query and you need to answer it at the same time. Then you will receive the next query. So that is the difference between online queries and offline queries. And like how people implement online queries is two ways. First way is this, that the answer of the query at for like query 1 will affect answer of query 2 because it will mutate the array. The second way is people can implement this in code force. So there are interactive problems. So in interactive problems you can also see this online queries topic, but here I don't think Leetcode has interactive problems. So yeah, here this is implementing online queries. But this is like I'm just using big words here. It is not really necessary that you need to know what online query is. This is very easy, like very much easy compared to online queries and all of those things. Yeah. Next query is 2LR. Compute the minimum number of sorry, compute the minimum number of character deletions required to make the substring else L2R alternating. Sorry. This operation does not modify s, the length of s remains s. So the first thing will mutate s, but the second query does not mutate s. And what is the second query is that you are given L2R and you have to make L2R alternating. So after A must come B, after B must come A. And how you can do this is you can delete any character from it. A substring is alternating with, that is fine. We all know what this is. Return an integer array answer where answer I is the result of the ith query of the type 2LR. So we need to find all the answer for the query 2LR and return it. Okay. So how you can do this is, let's take this case s equals to APA. Okay. I did not copy it. My bad. Okay. Yeah. So s equals to APA. Let's first actually let this like case be. Let's talk about how do you make a string alternating. So if let's say this is a string A, right? How you can make this alternating? Let's think about this. Okay, so the operation that you can have is delete any characters. So we can delete this, we can delete this, we can delete this. But is that really necessary? No. Which character should we delete? We should delete the character wherever si double equals to si minus 1. This is like not an alternating thing. If this is the case, we should delete it. And it's pretty like simple to see. Because see, we are having this A. This A does not match its previous value, or there's no actual previous value. So we should not delete it. This B is fine because this is fine. Now this three substring of B, this has three B's, but it can only have one B because the rest of them is alternating. So we will delete this, we'll delete this because it matches previous value. So the string would not become AB and we have deleted 2. Now this A does not match its previous value, so we'll not delete it. This B does not match its previous value, we'll not delete it. This A and this A, it matches previous value, so we'll delete it. So we need to do three operations. So to make any substring L to R, like alternating, how many operations you need to do. So the number of operations you need is actually this, right? How many times this thing is true, right? Is actually the count of times si double equals to si minus 1, right? Si minus 1. Okay. So we can just get the count of the total times si double equals to si minus 1 into in L to R. Okay, how we can do this? One way is prefix sum. The problem with using a prefix sum, so what I mean here is, see, for this thing, A triple B, A B, A A, here is this matching its previous value? No. Is this matching its previous value? No. Here it is matching. Here it is matching. No, 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 yes. So this becomes basic shim. And then let's say if the question says we'll need to convert this into an alternating strings, how much operations you need to do is basically the number of ones here, right? So there's two ones or the sum of this. You can say the sum of the substring L to R. So this like substring. Right? Okay, that is fine. But what is the problem here? How you can implement the sum? So you need the sum between L to R. How you can do this? The first way is to use prefix sum. But the problem with using prefix sum is the prefix sum. How much time will you take for each query? So each query you can do in O of one time, because prefix sum you can do prefix sum of R minus prefix sum of L minus 1. But the problem with using a prefix sum is update becomes very heavy, because see, if we were to change this b, if we were to change this b, or you get a flip query, so this was b before, now it becomes a. So if now it becomes a, then this index does not match its previous value again, so this has to be updated to 0, and the next also does not match its previous value, so this also has to get updated to 0. Okay, so now our array becomes this, and how you will have to update your prefix sum array. And how much time you will need to do is you will need to again create your prefix sum array. So that is why this becomes often, right? So we need a healthy balance between query and update. So query is often here. So this is not the way. You cannot use prefix sum here. The key to here is use segmentary. Now, if you that's why I said about this problem. If you know how to do segmentary equations, and if then a little bit even of segmentary equation, this is easy question. Uh, Let me give you a key, let me just give you the idea about segmentary. You can like forget how to implement it if you do not know this. I will give you the code of segmentary in my description below, or like in the solution, and you can look at the code. If you do not know how to implement it, let's just treat segmentary as a black box. So segmentary as a black box is basically does two operations. One is that it can query, or it can basically get the sum between L to R in log n time. So this is our sum segmentary. Here we are querying on sum. So it can get the sum between L to R in log n time, and it can also it can also update each value between update L to X. So it basically makes a L equals to X. Here our L X would be 0 to 1, right? So it can also do this in O of login time. So it can do both the operations in login time. So what would our time complexity become? So we have two queries. Each query we are answering in login time. So this becomes q login time, and q login time is very much fine. Okay, so we are treating segmentary as a black box here. If you want like a detailed video on segmentary, how to implement it, different types of segmentary, let me know in the comments. I can make that. But yeah, for this time, we can consider segmentary as a black box. Okay. So if this is fine. Now like this question becomes very easy. Why this question becomes very easy is we'll just do this thing. Will for each time. So I will create a segmentary. Let's call the segmentary as st or something like that. So st, I will create a segmentary object. Then I will find for each index if si double equals to si minus 1. I will set st dot update I to 1, right? This is basically will build our segmentary first. And then for each query, if it is like 2lr, I will get the answer as st dot query l2r. And if it is 1j, right, 1j, then I will flip sj I will flip our sj character, and this will only update its previous, only see if the string is like this: a b b a b a, right? If I am changing the, or I'm flipping this value, what is the, like the, what values are getting updated? So what is the current state of this is 0 0 1 0 1 0 1, right? Basically at what index is this equal to its previous? Basically where, what is, wherever is this thing through, right? So now if I'm flipping this, what are the values that gets changed? First is that its value will get changed, because if a b b, now it becomes equal to its neighbor, so b a b a, so it becomes equal to its neighbor, so this becomes 1 now, so 0 0 1 1, and its next neighbor now does not equal to itself, so now this would become 0 0 0 1. The key point to think is that only you need to only update the current updating value and the next value, so only j and j plus 1 should get updated, rest value is fine, we do not need to deal with that. Okay, so if it is 1j, we'll flip sj and we'll also update. So we'll do obj dot update on j and obj dot update j plus 1. So this is how we'll do, deal with both of the queries. This, hopefully you are able to understand it. Let me give you the code here. Let me show you the code here. One thing also you need to like note, and I got a wrong answer because I did not think this through, is what if the string is a b b a let's use this only, like this string, and do you need to find the number of removals you need to do for this string. So I will again not deal with this string, we will deal with this integer representation that we found out. Basically wherever is the previous value equal to this, so this becomes 0 0 1 0 1 0 uh, 0, right? Now you will get the sum for this part as 2, but obviously 2 is not the answer, because this string is actually b a a b a a b, right? b a a, okay, b, okay, 1 second, b a a b. So we'll get the answer as 1 plus 1 2, but that is not the answer. The correct answer is we just need to remove this, so the correct answer is 1. So why is this happening is basically, we are also dealing with this. So the actual answer is actually L plus 1 to R, because the first character will not consider. If it is equal to its neighbor, the neighbor is not in the array, or the left neighbor is not the array, not in the array. So the correct answer is between L plus 1 to R. Right. Okay. Let me show you the code now. So I'm not going to tell you like the sum segment tree implementation. I'm just going to tell you this is a struct. We are going to implement an object on it, and each of this operation update index val. So this is basically give me the index, give me the value that you want in this index, and the query is basically that, what is the query start and what is the query end, which is basically L to R, and what this will return the sum in that query, in that range L to R. So let me make this L plus 1 to 1. I implemented it in a slightly more difficult way. So yeah, as I said, we'll create a some segmentary object, and I'm like going over all that code for some segmentary will make it this video very big. So I go over all, as I said, will update only. So this basically sets all the values initially to 0. Now we'll only update the value where si equals to si minus 1 as 1, else we'll keep that value to 1. Then we'll go over all the queries. If this is an one query, so this is an update query. I will flip the jth character, and as I said, will if this jth flip will only update its value and its next value, because this the value we are keeping is this equals to I minus 1, or the previous value. So again we go over the previous value. If this becomes equal, then we'll do update on j equals to 1, else we'll keep it as else we'll update to 0. Yeah, again, also we will do the same for the next value. If it is equal to, the next value is equals to its previous value, then we'll update the next value as well. Else we'll keep it as, else we'll update it to 0. And if this is a second query type, then we'll get the answer as obj.query between L plus 1 to R, and I will just push back into current answer, right? So the answer is basically the number of times this thing is true at si equals to si minus 1 between L plus 1 to R. This is our, I will add it to answer and return answer. So I can submit this. Now the contest is over. Yeah, and this works. Thank you for watching. If you were able to understand anything, if you need any support, also let me know in the comments below. And yeah, thanks for watching. If you were able to understand anything, give me a like and subscribe. All of those things. Bye bye.